I think we stopped here, right? So this would be video number 3 for topic 6. So let's move forward to that one. Okay, so the health effect continues. Hazardous air pollutant HAPs. The mercury can attack the brain, kidneys, and bowels. Other potential effects from the HAPs are birth defects and damage to the immune and nervous system. Then the next one, the lead. Lead is also a primary pollutant, right? Criteria pollutant in this case. So lead is a cumulative poison. Lead is ingested in food and water as well as being inhaled because of particulate one. Of that portion taken by ingestion, so it looks like approximately 5 to 10% is absorbed in the body. Between 20 to 50% of the inspired portion is absorbed, and unabsorbed portion are excreted in the feces and urine, basically. So that's what happens most of the time. So lead is measured in the urine and blood for diagnostic evidence for lead poisoning. Lead levels in the blood excess of 80 microgram per 100 gram of the body weight or things like that, or gram of the blood results in constipation and abnormal cramps, abdominal cramps. When acute exposure results in blood levels, lead is basically 120 microgram per 100 gram, acute brain damage might happen. Such acute exposure results in convulsions, coma, respiratory arrest, and death. Acute exposure may occur over a period of 1 to 3 weeks. So chronic exposure to lead may result in brain damage characterized by seizure, mental incompetence, and active aggressive behavior. So some people might have this issue if they have exposure to a certain level. Weakness of extensor muscles and hands and feet. Eventual paralysis may also result. Atmospheric lead occurs as a particulate. The particle size ranges from 0.16 to 0.43 micron. The next one is nitrogen dioxide. So exposure to nitrogen dioxide concentration above 5 ppm for 15 minutes result in cough and irritation of the respiratory tract system. Continued exposure may produce an abnormal accumulation of fluid in the lung. It's called the pulmonary edema. So nitrogen dioxide gas is reddish brown in concentrated form and gives a brownish yellow tint at lower concentrations. At 5 ppm, it has a pungent, sweetish odor. The average concentration of nitrogen dioxide in tobacco smoke is about 5 ppm. So that's why tobacco may not be a good idea, right? Then effects on health, the photochemical oxidant. All the photochemical oxidant include pyroxyacetylene nitrate (PAN), acrolein, peroxybenzenyl nitrate, and nitrogen oxide. The major oxidant is the ozone. So already I mentioned that. That's why ozone is called the secondary criteria pollutant. Ozone is commonly used as an indicator of the total amount of oxygen present. Oxygen concentration above 0.1 ppm result in eye irritation. Concentration of 0.3 ppm, cough and chest discomfort are increased. Those people who suffer from chronic respiratory disease are particularly susceptible to the ozone or the photochemical oxidant. Then PM10, large particles are not inhaled deeply into the lung. This is why EPA switched from the air quality standard based on the total suspended matter to one based on the particles with aerodynamic diameter. So here is the definition of aerodynamic diameter. So irregular particle is defined as the diameter of the spherical particle with a density of 1000 kg per meter cube and the same settling velocity as the irregular particle. So that's what the diameter is less than 10 micron. Levels of PM10 increase the risk of respiratory, cardiovascular, and cancer-related deaths, as well as pneumonia, lung function loss, and asthma. So asthma is the main problem. Recent studies have pointed toward particle size less than 2.5 micron as a major contributor to elevated death rates in polluted cities. So, however, a suitable biological mechanism to explain what causes the death is lacking. on that. Nonetheless, in order to provide the adequate margin of safety, EPA administrator proposed a new standard based on PM 2.5 in July 97. It may not be in effect already. So then sulfur oxide, total suspended TSP. Sulfur oxide includes sulfur dioxide, sulfur trioxide, their acids, and the salts of their acids. Rather than separating the effects of sulfur dioxide and trioxide, they are usually treated together, although there is a speculation that a definite synergism exists, whereby fine particulates carry observed sulfur dioxide to lower respiratory tract. The sulfur dioxide, in the absence of particulates, would be absorbed in the mucous membranes of the upper respiratory tract. So patients suffering from chronic bronchitis have shown an increase in respiratory symptoms when TSP levels exceed 350 micrometer cube of and level of sulfur dioxide as 0.095 ppm. Studied in Holland at an interval of 3 years showed that pulmonary function improved as sulfur dioxide TSP level dropped 0.1 ppm and 230 microgram per meter cube to 0.03 ppm to and 80 microgram per meter cube respectively. The air pollution disaster call episode summarized in table 9.5 in the book. You can take a look. This will explain like what time and when and how many people died in different air pollution issues due to air pollution issues and other things. So origin and fate of air pollutants, we'll go discuss by that now. So carbon monoxide is one of them. As I said, carbon monoxide, lead, nitrogen oxide, sulfur particulates matter. These are the 5 primary criteria pollutant. And photochemical oxygen or ozone could be one of them. And HAPS is 189 HAPS are there. Carbon monoxide. Basically, carbon monoxide comes from the basically driving car and other things. The main source is incomplete oxidation of carbon results in production of carbon monoxide. The natural aerobic decomposition of carbonaceous material by soil microorganisms release also approximately that moles of methane to the atmosphere because if it is anaerobic. Aerobic, it doesn't create any methane. The natural formation of carbon monoxide results from an immediate step in the oxidation of methane. The hydroxyl radical serves as the initial oxidizing agent. It combines with methane to form the alkaline radical. So this is the main thing. And after 39 series of complex reactions, basically this one oxygen with the this thing, carbon monoxide, hydrogen, and hydroxyl ion. So these are the long forms. Anthropogenic source. Anthropogenic source mainly the human source and natural source definitely. So those associated with activities of human beings include motor vehicles, fossil fuel burning for electricity and heat, industrial processes, solid waste disposal, and miscellaneous burning of such things as leaves and brushes generate the carbon monoxide. Approximately 10 to the 13 moles of carbon monoxide are released by these sources each year. About 60% of it comes from the motor vehicle emissions. No significant changes in the global atmospheric carbon monoxide level has been observed about the past 20 years. So HAPS, the EPA identified 166 categories of major sources and 8 categories of area sources for the 189 HAPS listed in the literature. In our book is table 9.2. The source categories represent a wide range of industrial groups such as one could be this is table 614, combustion, metal processing, petroleum, natural gas, surface coating, waste treatment, disposal process, agriculture, chemicals, polymers, and resin productions. These are the ones. There are also a number of miscellaneous source categories such as dry cleaning and electroplating companies. They might do a little bit of HAPS too. In addition to those direct emissions, air toxics can result from chemical formation reactions in the atmosphere. These reactions involve chemical emitted to the atmosphere that are not listed in the HAPS and may not be toxic themselves but can undergo atmospheric transformation to generate HAPS. So lead, volcanic activity, airborne soil are the primary sources of the atmospheric lead. Smelters and refining process as well as incineration of lead containing waste are major sources of lead. So approximately 70 to 80% of lead which used to be added to the gasoline was discarded to the atmosphere. Now still we see leaded and unleaded gasoline, right? Submicron lead particles which are formed by volatilization and the subsequent condensation attached to larger particles, they form nuclei before they are removed from the atmosphere. Once they have attained the size several microns, they are either settled out or washed out by the rain. So that's the layer. So this one, it shows the atmospheric temperature and pressure. The main reason of showing it because it shows us a little bit of ideas like where it can happen, and if something is certain level, then we can be affected by that. Okay, so that's the reason I'm showing that. So you might have studied those in fluid mechanics, right? So this is the pressure line, this is the temperature. So temperature goes down with the altitude, then in here stratosphere it goes up, and in the stratopause it remains same, and here it is mesopause also remains same. Here it is stratopause, uh, tropopause has remained same also. So this is shows the location of the ozone in this case. So this is the starting. So we are here in the earth places, troposphere, clouds, then ozone layer. Ozone layer is something right after that. So this ozone layer is very helpful for us. It protects the ultraviolet ray from the sun, whereas the ozone itself, when it goes here, it gives us skin irritation and other things. So this looks like a solar system and the different layers of the atmospheric system and other things like that. So here are the satellites, exosphere, so that we don't even thermosphere, then above it, all of those are kind of the location of those things. Okay, nitrogen dioxide, bacterial action in the soil release nitrous oxide to the atmosphere. In the upper atmosphere or stratosphere, atomic oxygen reacts with the nitrous oxide to form nitric oxide. So that means this is the reaction. The nitric oxide again reacts with the ozone here, become nitrogen dioxide and oxygen. The global formation of nitrogen dioxide by this process is estimated to be 0.45 petagram, means 10 to the power 5, 15 gram is equal to 1 petagram in volume. So combustion process accounts for 96% of the anthropogenic sources of nitrogen dioxide. So nitrogen and oxygen coexist in the atmosphere without reaction, but at a high temperature in excess of 1600 Kelvin, they react, nitrogen and oxygen become nitrous oxide. And from the nitrous oxide, then we have seen the reaction over there. So it with the ozone, it becomes the nitrogen dioxide and oxygen. So ultimately, the nitrogen dioxide is converted to nitrite in particulate form, and these particulates are then washed out by the precipitation. The dissolution of nitrate in a droplet allows for the formation of nitric acid. This is in part accounts for the acid rain found downwind of the industrial areas. Photochemical oxidant, as we know that this is the secondary pollutant. Basically, nitrogen dioxide and the oxygen combined creates the nitrogen and ozone. They are formed in the series of reactions that are initiated by the absorption of a photon by an atom molecule, free radical ion. Ozone is the principal photochemical oxidant. Its formation is usually attributed to the nitrogen photolytic cycle. Hydrocarbon modify this cycle by reacting with atomic oxygen to form the free radical and things like that. So the hydrocarbon, nitrogen oxide and ozone react and interact to produce more nitrogen dioxide and ozone. The whole reaction sequence depends on the abundance of sunshine. So as a result, these reactions is the photochemical smog, for which Los Angeles is famous for, right? So yeah, I think we can stop over here and make a. This is the third one, so this would be the third one. So we can stop here.